There are lots of ways of thinking about functions, and I find that even though we've worked with functions for a long time, often we're missing some of these details. You can think about a function in words. You can think about a function in terms of its graph or a plot. You can think about it in terms of numbers or data, and you can think about it in terms of symbols. Probably remember the mathematical definition of function is a relation between elements from the domain and the codomain, such that each element in the domain is mapped to exactly one element in the codomain. Another way to think about it is a function from x to y is a magic lizard that knows how to eat something from x, chew it for a bit, and spit out something in y. And often this chewing process, there might be different ways that you can realize it. In other words, the process of actually calculating the function value, there might be different options that you have. The most basic example you can think of is something like f from the real numbers to the real numbers, where x is mapped to x squared. But there are lots of other functions. It's perfectly valid to define a function just in terms of a table. So here the domain is just the numbers 1, 2, 3, and the codomain is just the numbers 2, 3, 4. And for each of the numbers 1, 2, and 3, I have this function called bob, and the table tells what the value of bob of x is. Another function that you're probably familiar with would be the 9-2 lookup function. So the domain would be the names of WCU students, and the codomain would be 9-digit numbers beginning with 9-2. And here we're seeing that functions don't necessarily even have formulas. They don't have to be dealing with numbers. And when they deal with numbers, those numbers don't have to be interpreted quantitatively. As another example, we can look at the function defined by the North Carolina Department of Motor Vehicles. The input would be something like the VIN number, the vehicle identification number, which is actually a 17-digit code that tells you the origin of the car, where it was built, the manufacturer, and engine size, security code, model year, all this information. And so in some sense, the VIN number is like the identifier of my van. So the input would be the VIN number, and the output of the function would be the license plate number, which actually number that is on the back of my van and is used to reference it in other situations. But even though we're going from numbers to numbers, there's no formula. It's not like we square the VIN number. It's just an association, and it's stored in a massive computer database. And that database is probably the only way you could represent this function. Another example we could look at is something that takes as input a temperature. So I can input any number in theory, although there might be physical constraints, but the output will be a state. And that state will either be solid, which is ice, liquid, or gas. It's helpful to use what I call if-then thinking here, which is that you're just recognizing you're going to be checking lots of if question or if conditions. For instance, if I call this temperature measurement T, small t, then I can start by saying if T is less than or equal to 32, the answer is solid. If T is greater than 32 and less than or equal to 212, the answer is liquid. And if T is greater than 212, the answer is gas. Now, I'm actually not sure. I'm not a physicist, so I don't remember off the top of my head. Less than or equal to or less than, and we could fix the details of that. But the big idea here is that the output of the function is not a number. Rather, it's a verbal description of solid, liquid, or gas. So two functions are the same mathematically speaking if they have the same domain, the same codomain, and the same outputs over all inputs. So it's possible for two different functions to actually be the same function, even if they're written in a different way. So let's consider these two functions. F from R to R, given by f of x equals x squared, and g from the reals to the reals, given by g of x equals x squared plus 1 minus 1. And the question I have is, are these the same function? The answer is yes. No matter which value of x you plug in the domain, you'll get exactly the same answer, even though the formulas are written differently. So here's another example of a function. We could say theta is a function from the reals to the reals, and theta is defined as the quadratic function that passes through the points -1, 0, 0, 3, and 1, 0. And now when we think about functions in this way, we have a whole new set of questions that we have to worry about. Like, how do we know that there is even such a function? How do we know this function exists? How do you know there's only one function? How do you know you've specified enough information to tell you that if there is one, this is the only one? The final thing is, can you find a formula for the function? What process would you use to calculate theta of 2 given this information?